Welcome back to the 60-Day Cloud Security Challenge. Day 5, and we are moving from IAM to network security. Specifically, VPC architecture. If IAM controls who can do what, VPC controls where traffic can flow. You need both layers locked down, because an overly permissive network can expose resources even when your IAM policies are perfect. Let us dig into how VPCs actually work and how to architect them securely. First, what is a VPC? It stands for Virtual Private Cloud, and it is your own isolated network inside AWS. Google Cloud and Azure have equivalents called VPC and VNet. You define a CIDR block, which is just an IP address range, and that becomes your network. A/16 gives you about 65,000 addresses. The critical thing to understand is that a fresh VPC is completely isolated. Nothing gets in, nothing gets out, unless you explicitly create a path. That default deny posture is your starting point. Now, here is where people make their first mistake: CIDR planning. Every VPC needs a unique, non-overlapping CIDR range if you ever want to connect them via peering or transit gateway. I have seen teams use 10.0.0.0.16 for every VPC and then discover they cannot peer them. Plan your ranges up front. Production gets 10.0, staging gets 10.1, dev gets 10.2. Write it down. Stick to it. Next, subnets. This is where most security misconfigurations happen. A subnet is a slice of your VPC's IP range, and the critical security question is it public or private? Here is the thing that trips people up: there is no inherent public or private label on a subnet. A subnet is public if and only if its route table has a route to an internet gateway. If it routes to a NAT gateway instead, it is private. That is the entire distinction. So when you create a subnet and name it private, subnet 1A, that name means nothing to AWS. What matters is which route table it is associated with. And here is the really dangerous part. If you forget to associate a subnet with any route table, it automatically uses the VPC's main route table. If that main table has an internet gateway route, maybe you added one during initial testing and forgot to remove it, then your so-called private subnet is actually public. Resources in it are reachable from the internet. The fix is straightforward. Rule number 1, never add internet gateway routes to the main route table. Keep the main table clean with only the local route. Rule number 2, always explicitly associate every subnet with a named route table. No exceptions. The standard production pattern is 3 tiers. Public subnets for load balancers and NAT gateways only. Private subnets for application servers, containers, and compute. Database subnets for RDS, Elasticache, and data stores. The database tier should have no internet route at all, not even through a NAT gateway. If your database needs to reach the internet, rethink your architecture. Deploy across at least 2 availability zones for each tier. That means 6 subnets minimum, 2 public, 2 private, 2 database. Let us talk about VPC endpoints, because this is money and security on the table that a lot of teams leave behind. When your private EC2 instance calls S3, that traffic by default goes through your NAT gateway, out to the public internet, and back to the S3 service endpoint. You are paying NAT gateway data processing fees, about 4.5 cents per gigabyte, for traffic that never needs to leave the AWS network. Gateway endpoints for S3 and DynamoDB are completely free. They add a route table entry that sends service-bound traffic directly over the AWS backbone. No NAT gateway, no internet traversal, faster and more secure. For other services like Secrets Manager, KMS, SQS, and ECR, you use interface endpoints. These cost about $7 per month per AZ, but they create a private network interface in your subnet so traffic stays internal. The bonus is endpoint policies. You can restrict exactly which S3 buckets or KMS keys are accessible through each endpoint, adding another layer of access control beyond IAM. Finally, visibility. VPC. Flow logs capture metadata about every network connection in your VPC, source and destination IPs, ports, protocol, whether traffic was accepted or rejected. Turn them on for all traffic, not just rejected traffic. Accepted connections from unexpected sources are often more concerning than blocked ones. Send flow logs to both CloudWatch for real-time alerting and S3 for long-term analysis with Athena. A simple Athena query can find accepted connections to sensitive ports like SSH, RDP, or database ports from outside your VPC CIDR. If that query returns results in production, you have a misconfiguration to fix immediately. Quick recap of your VPC security checklist. Plan non-overlapping CIDRs up front. Never put IGW routes on the main route table. Explicitly associate every subnet with a route table. Deploy NAT gateways in each AZ. Create gateway endpoints for S3 and DynamoDB. Turn on flow logs for all traffic. Tomorrow on day 6, we layer security groups and NACLs on top of this foundation, adding port-level firewall rules. And day 7 is a hands-on practice day where we build a secure VPC from scratch. See you then.